This is the news story of a 20,000-year-old transformer that was found in Kosovo. So the idea of a Stone Age, a Bronze Age, and an Iron Age in archaeology, and followed by a technological age, should be reconsidered, because here we have wire, it looks like copper wire, that is in a transformer, and this is so long ago that archaeologists probably are going to say that this is the Stone Age. Look, it's half turned to stone. So it's turned to stone in a fossil, and that does not mean it's Stone Age technology. And then just because the wire is copper, that doesn't mean that it's Bronze Age technology. And that's not even a transformer that we could use in today's world. This is some sort of Tesla device. So these artifacts are anomalous parts, out of place artifacts. I'm going to be having tea and crumpets during this talk. So these are crumpets. So crumpets, we don't know what they are. They're not English muffins. So crumpet tastes something like a lot of baking powder, flour, and shortening, and they're kind of rubbery. If you don't put anything on them, you're going to get a mouthful of baking powder. You see people putting jams and preserves on their crumpets. So you can get the flavor of tea better with a crumpet. So when you're drinking tea, everybody else is drinking tea. They're having crumpets. So when you're tasting tea, maybe you should have a crumpet or a biscuit or something. If you just eat a crumpet raw, it's rubbery like a dishwasher sponge. It's almost like those inserts of a push-up bra. Or one of those hiking soles you put, those so when you're hiking, your foot doesn't get tired. And they're heavy, so if you don't want to take them with you hiking, they have like other stuff you could take with you hiking that's lighter if you want to take, and you have your tea. So I drink maybe tea and coffee equally. I like good tea, I like good coffee. It seems like a lot of our conspiracy YouTubers are always in hotels. If you're a UFO YouTuber, or you're talking about ancient technology or anything in archaeology, you see us, we're always eating, or we're always in a hotel. We're always in a hotel somewhere, like we're trying, I mean, and eating. So you start talking about UFOs and stuff, you're going to wonder, you're going to see all kinds of things you weren't prepared for. People tracking you, your hotels searched, everything. So these Kosovo artifacts, this site, to me it looks like a Tesla coil. So it's not a spark plug. If you look at a spark plug, it doesn't have a coil around the insulator. So there's an insulator there. There's a top to it and a toroid where the wires are going vertical around a toroid. So when you wrap a coil like that, so you might see a coil wrap like that for noise reduction in audio engineering or something like that. But the turns of coil around that toroid is going to determine that frequency. What's really interesting is there's a secondary coil on top. I don't know if it's missing or it's in the stone. Maybe it's in the bottom. When you stack a coil, or maybe in the toroid is a coil, but let's say we're looking at these artifacts and there's a coil on top. That's a Tesla coil. So you're converting. So what does a transformer do? So a transformer converts, let's say 120 volts to 6.3 volts. So on your primary you have 120 volts. On your secondary, out comes 6.3 volts. And the way you're doing that is you're converting the energy with a loss across from the primary to the secondary. Then there's a counter EMF. It's part of your loss. So you can go in to your shop, you can wind your own transformer if you want to, and try to reduce the counter EMF. There's counter EMF on the transformer. It's going to send an eddy current through your hardware. So if you so what's going on, you know, so the voltage, so matter is never created or destroyed, neither is energy. So the voltage and current have to, so if right, so the current is going to go up across the secondary from 120 volts to 6.3 volts. The voltage goes down on the secondary, but you're going to have some current, right? Depending on what your load is on the secondary coil. So all these are, that's a 6.3 voltage on a secondary is what you would use for a 5 volt power supply for a computer chip. So the 6.3 volts AC on the secondary of the coil, of our hypothetical coil, is put through some diodes. So from 6.3 it goes into 5 volts pulsating DC. And then you have to take that ripple out of the 5 volts. So you may end up with 4.8 volts by the time you're done cleaning up that signal, right? We all know this because we have voltmeters and oscilloscopes. So you just don't make a transformer without a voltmeter, oscilloscope. Not only, how did they, okay, so this is a 20,000-year-old transformer. So when I look at this transformer, what's going through my mind is the primary, the secondary. You could tell the voltage of the primary by the diameter of the wire. So the thicker the wire, the higher the voltage, generally. So this is carrying a lot of voltage, AC voltage. You only use transformers for alternating current AC voltage. Coils are only used in alternating current AC voltage for a coil to work. So that's the first assumption you can make with this Kosovo transformer. Alternating current. It is high voltage. And there's a lot of current on the primary and a lot of voltage on the primary. So what happens in a Tesla coil is you have a lot of turns on the primary and few turns on the secondary. And you're using voltage to jump the air gap. So you're making a lot of volts. You're upping the AC volts, and the current goes down because your voltage goes up. In that device, when your voltage goes up, in a Tesla coil device, when your voltage goes up, your current goes down. But that's not a small device. That's a giant something or other. I don't know if it's exactly a Tesla coil either. So a Tesla coil, maybe you would have a few turns on the primary and a lot of turns on the secondary to make the voltage go up. So if you see the Tesla coil right before the spark electrode, you always see a lot of turns on their coils, and the diameter of the wire is small. The primary of a Tesla coil. So there's some Tesla coils that not only is it large diameter wire on the primary, it's flattened copper banding and a toroid. But what I've noticed about Tesla coils that we think of now is that there's air in the inside the torus. That Kosovo transformer is a coil, and the wire looks square. They're making square wire, and it is wrapped around some sort of iron core toroid with the coils like this. So the torus is going to have the counter EMF. But what they have that we don't is in the Kosovo transformer, not only is it wrapped around a toroid, there's the insulator coming up in a tall fashion. We don't even do that. We don't have anything like that on our transformers. That's weird. So, and then we don't know, like, so 20,000 years ago, there's no 60 cycle power grid. In the United States, it's 60 cycles. In England and Europe, it's 50. So you could actually probably get the frequency of the AC by the coil. So I'm thinking It's about 1,000 hertz on the primary. So where does the frequency come in AC in the electrical power grid in North America? We have dams of water, and the water goes through a spill gate and pushes a generator. The generator turns around 60 times a second. 60 seconds. 60 CPS, 60 cycles per second. That's how fast the shaft of the generator is turning at the dam power station. That frequency is sent to your computer transformer. That same 60 cycles. The Kosovo transformer looks like it's working at 1,000 cycles per second. What the hell works at 1,000 cycles per second? See, like, the way why you choose your frequency is wire has transmission characteristics. Signal loss. If it's a Tesla coil, that's how they're powering the Dendera bulbs. So everyone's familiar with the Dendera bulbs and the Egyptian carvings. They have these bulbs that light up, lighting the interior of the pyramid. The thing about Tesla coil power, I just hold the bulb in the air and the electricity goes through the air and lights the bulb. So then the primary of those Kosovo transformers, so I'll probably guarantee you Kosovo transformers are Tesla coils, and they're powering the Dendera bulb devices. And there's something going on with the insulator. Maybe it's so there's the individual who wrote the article has a circuit diagram for the Kosovo transformer. He's saying it's a 3-phase transformer. That's how we think of delivering electrical power on the power grid in our modern mind. The engineers 20,000 years ago, nobody knows what they're thinking. The thing about electricity is electricity works the same all over the universe. The laws of electricity are the same. 1,000 cycles per second. Maybe the Tesla coil electricity travels a farther distance with 1,000 cycles per second instead of 60 cycles per second that we have here. Because so 1,000 cycles per second is RF. It's already a radio frequency by the time it reaches 1,000. Who knows? Maybe it could go quite a distance. If you look at a walkie-talkie, What is the diameter of wire in a small walkie-talkie? 18 gauge wire in the antenna. Look at that Tesla coil, that Kosovo transformer. That's a globe spanning RF generator. That comes from an RF generator. It looks like a duplex communication output transformer of a Tesla coil RF generator. There's also a Van de Graaff generator. So the Kosovo transformer is not a static electricity device. That's a practical. So the ancients are very practical. You know, the arch. It's not that they're making an arch for the hell of it. It's functional. It supports the load. They didn't build the pyramids for the hell of it. We're gonna go half cocked and drink some Egyptian beer. Egyptian beer is very good, by the way. You drink some Egyptian beer, you're gonna get half cocked and you're gonna do all kinds of shit. I guarantee you, no matter how much Egyptian beer you've drinking, you're not gonna build a pyramid. There were pharaohs that ordered their men to remove those pyramids and they couldn't even do it. I think Ramses ordered the destruction of the pyramids. They couldn't do it. It was this eyesore on the Giza Plateau. He said, he thought, you know. And there was evidence that there's all kinds of stuff on the Giza Plateau. There's still a petrified forest over there. Unexplored. Nobody gives a rat's ass. Nobody gives a shit. Oh, this is a petrified forest full of artifacts. You know? There was only one ancient civilization, right? We already know where it was. Giza, Heliopolis, and Athens. And so, no. I mean, there's probably many things yet to be discovered over there. The Giza Plateau, Fayum, the petrified forest. There's people locating. I've seen videos. There was a woman who was doing like her paper at school, famous school. I think it was her PhD paper, looking at satellite maps, looking for the other pyramids there. And she's got them. Other pyramids. But in Kosovo, right? So the transformer. I mean, there's got to be other artifacts there. Like where is the rest of the machinery? So with a Tesla coil, you're just sending the power, and then your machineries are the other devices. There's no wire connecting any devices. Wireless. Bluetooth, if you will. Okay? That Kosovo transformer, to put it in a language that you could probably determine as practical for yourself, is a 20,000-year-old Bluetooth device. They probably used their brains as the computers. So you had your device, and your brain went to a bracelet you were wearing, and the bracelet tuned to the frequency of the Kosovo transformer. That's the device. Where's their computer? They use their head. And then we're talking elongated skull people building those Tesla coils, building the pyramids. Not to mention, like I said, you get into this UFO talk with, as soon as you start getting into like that Kosovo transformer, maybe it's powering directly a UFO grid for worldwide travel. The Vimanas, the traveling Vimanas that levitate on the ancient power grid. So you would have a coil in your Vimana tuned to that Kosovo transformer, and when the Kosovo transformer is powered up, your Vimana is powered up, wireless, or drones or something, you know. But that Kosovo transformer is not how we think of electricity and transformers in today. And I think it's a big story. It's getting ignored and everything. It's a transformer. It's turned to stone. And I think it deserves a lot of investigation, obviously.